Hello, hello. Since you guys are here first, feel free to ask a first question. Welcome, folks. And I just want to let you know we're recording. I have to record for people who can't make it. So feel free to get going. If anyone has a question, happy to take it. Or you can wait to see until someone does.
I had a question on the review packet.
Yeah.
It was question number 6, and it was part C.
Okay. This is a perfect time for me to test if I can open up my iPad here. iPad and cable. All right, let's see. Ryan, can you see that?
Yeah,
Okay, great. Okay, so 6C. Let's see here. Yes. Okay, this is the inverse cosine of cosine 3.3.
yeah.
Yeah, so one thing with all these problems, I always ask myself, what do things stand for? And what is 3.3 standing for?
Instead of the angle, like pi
It's,
or
it's an angle, right? Like, because you're inputting it into the regular cosine function. And so 3.3, what quadrant would that angle be in?
that's in quadrant 3.
Right. So this would be 3.3. And where cosine's negative, right? So if I'm in doing inverse cosine of a negative ratio, what quadrant angle do I want to spit out?
We want quadrant 2.
Quadrant two. So for me, kind of the easiest way to think about this, because you can always do this particular method, is you can always get the reference angle. So if 3.3 is the full angle, remember the reference angle is always the distance between the terminal side and the closest x-axis. So in this case, the reference angle would be 3.3 minus,
Raymond.
oh, hello, 3.3 minus pi. Are you with me, Ryan?
Yeah.
Okay, so then remember to get a quadrant two angle, it's always pi minus that reference angle. So I can do pi minus this 3.3 minus pi, which is going to give me 2 pi minus 3.3.
Okay, thank you.
Yeah, because sometimes it's confusing to think, oh, am I going to pi? How do I get there? Always a safe bet is you can find the reference angle. And once you have a reference angle, you can find any quadrant you want. Liam, yes.
I had a question on 5 for finding the peaks.
Yes.
So I had it as like negative 1/2 equals sine of whatever's inside. But then when I checked the answer key, it was like negative pi over 2.
Um, oh yeah. Okay. So normally the peaks occur. So to figure out where the peaks occur, we're looking at it's like a domain transformation, right?
Yeah.
And so normally for sine, the peaks occur every pi over 2 plus 2k pi. But because it's a negative amplitude, there's two ways you could do it. You could either set it equal to 3 pi over 2, because it's a negative amplitude, it's going to be where the troughs normally are.
Okay.
Or I don't know, I would like to work with smaller fractions. So equivalent kind of equivalent way to do it is just set it equal to negative pi over 2 because those are
Okay.
coterminal angles. So they're ending in either one works.
Okay.
So did you do one of those?
I'll try one of those because I was doing it still as if 1/2 was positive,
Oh,
like the positive angle.
Okay, yeah. So if you're setting it equal to pi over 2 plus 2k pi, that would be if there was a positive amplitude.
Yeah,
This is for the peak part, right?
yeah.
Yeah, exactly. So yeah, so you either set it to now because it's negative, you're setting it the inside equal to normally where the troughs are.
Okay, thank you.
What else do people got for me?
Can you please explain question number 12 on the packet?
Same packet, Alan?
Yeah.
Okay, so let's see. Let's zip over to 12. Yeah, okay. So this one's a little bit complicated. So thinking about where cosine of, so I think when always I have an inequality, I first think of equality a bit, and then from there I can go to the inequality piece. So if we were solving like cosine of 5 theta equals 0.5 or a half, the first thing I would do is really think about cosine of x equals a half, right? Usually we find what it is, we do a substitution and find what the angle if it was singular was, and then we would divide by 5 at the end. So I would do that here. And for me, the easiest way to think about this, because especially because it was an inequality, was to just think about if I had a graph and I'm just thinking about the graph of cosine of x. So cosine of x looks like this. And where does cosine equal a half? Like if I think about that, it equals a half at pi over 3, and then in quadrant 4 at 5 pi over 3, and so on. So if I think of quadrant 1, so let's draw a half. So this would be y equals a half. So I think this is the first time to the right of the y-axis that it's a half would be pi over 3. And then the second time in that fourth quadrant would be 5 pi over 3, and so on. So I want to think of all values here. And it just keeps repeating. So in other words, I'm thinking, okay, it's less than 0.5 for all values between pi over 3 plus 2k pi and 5 pi over 3 plus 2k pi. Like every time I go a cycle away, as long as I'm between those two equivalent values, it'll be less than a half. Does that make sense so far, Alan?
Yeah.
Okay, so then, oops, I forgot the less than. So then remember what x was? It was 5 theta. So let's just replace, if I want it to be, if x is 5 theta, I'm just going to rewrite it with 5 theta. Then let's solve for theta. So to solve for theta, I'm just dividing everything by 5. So it'd be every pi over 15 plus 2k pi over 5, and every pi over 3 plus 2k pi over 5. And that's it for that one. So sometimes like getting a sense of with an inequality, like I don't want where it's greater than a half. If it was greater than a half, I'm thinking like, between these 2 points here. But because it was less than a half, so that's why it helped me to visualize it with a graph so I could figure out kind of what intervals am I looking at.
Okay, thank you.
Oh, Devin.
Sorry, wait, I just figured it out. Sorry.
Okay, Ryan.
I had a question on the next problem, number 13.
Yeah. So finding sine of y in terms of x, right? So I'm going to rewrite it like this. I don't know why arc bothers me, but it does bother me. So I just prefer writing it with the superscript of -1. But okay, so now we want to find what sine of y is. So to find sine of y, that just involves taking the sine of both sides. So sine of y is going to be sine of inverse tangent of x. So this type of problem, so it's this came up in at least one of the blocks today. Just make sure that you are thinking about when you're dealing with something like this. Notice the outer function is a regular trig function. So your answer is going to be a ratio. So you never need to know any specific angles. So if I'm solving for a ratio, that's often going to involve drawing a triangle. So if I want this inside means some tangent of theta equals x or x over 1. So if we draw a triangle where that's the case, so x over 1, then I can find the hypotenuse, which is just the square root of x squared plus 1. So then the sine of the inverse tangent of x is just going to be, so sine y is just going to be x over the square root of x squared plus 1. And no need to rationalize if there's variables under a radical. Just leave it as is. You rationalize if there's just numbers under a radical in the denominator, but if there's variables, just leave it as is. So
Okay.
that's all. Does that make
Thank you.
sense?
Yeah.
It's kind of similar to that one we had in that review sheet in class today where I said like fine, it was something like sine of inverse cosine of x over 4, and you had to create a triangle and things like that in terms of x. How was I'm looking at the review packet here. How was number 16, like the domain and range problems? That was all these babies that went on for this page and the next page. Because kind of like every test, you're going to have a domain and range section. So it involves, of course, knowing the domain and range of all the regular trig functions, but also the inverse trig functions. So just make sure you're eyeballing, am I working with a regular trig function or am I working with an inverse trig function? Because that'll be important to think about. Yeah, Daniel.
For like the graphing questions,
Yeah.
the absolute value, sometimes it's like reflected like from the negative to the positive, and then it creates like the bumps. But then sometimes like the bumps, some are like high and some are lower.
Oh
How do
yeah,
you
yeah. You're talking about when we did the graphing, right? Like forget what pack. Yes. Yeah, that packet, right. And
how
then
do you know?
that's when you want to let me see if I can find what packet that was, if I can remember. It was right after the quiz. It may have been like 6.6. Let me see. And that's when I said you want to do that in stages, those graphs, right? I don't tend to jump right to the absolute value. Instead, and by the way, we would only be doing absolute values in the y's, not absolute value in x with trig, like I gave you on these. Let me see if I can find it. maybe. Yes. I think it was these, right? These two here.
Yeah.
Yeah. Um, yeah. So what was your question about those?
Like, how do you know when it's just reflected over, or like when it's restricted to just positives
Well,
versus
so that's why you kind of don't, you have to kind of do it in stages. So, for example, in this case, I would first graph, like if you want to really be certain, you first would graph cosine of x over 2, that function. And then when you graph cosine of x over 2, what's the difference between how is cosine of x over 2 normal from different cosine from the normal cosine? How is it different from the normal cosine of x? Do you remember? Like, what would be the only difference between if I were to draw cosine of x versus cosine of x over 2? The only difference would be the period, right? What's the period of this function? It would be 4 pi, right? So if I'm drawing this, I would first draw 3 pi. I'm just going to quickly sketch this here. I would first draw what this is. Again, I'm just drawing cosine of x over 2. That. And once I've done that, let me just make sure, negative 4 pi, 4 pi. Then I tackle the absolute value, right? Because the absolute value then means everything that's negative becomes positive. So now I've got this blue graph. So now I've graphed the absolute value of x cosine of x over 2. And from there, I'm going to multiply all the y values by 3. So, and then shift down 1. So this is an example of how they're going to be the same hills, exactly the same. Um, and uh, and then so that's why I like to do it in stages, Daniel, if I'm being honest, just so that I make sure that I don't make any assumptions. Does that make sense? Wait, did I lose Daniel? Daniel, you there? Can you guys hear
I
me?
don't think his mic is working.
Okay. I was like, can anyone hear me? Um, oh yeah, sorry, Daniel. I see you just wrote in the chat your mic isn't working. So maybe write in the chat, does that make sense to you? Because then if I were to graph this next one here, this in some ways seems easier to graph to me because then I literally do this whole piece first. I'm just going to graph 3 cosine x over 2 minus 1, that graph. And then I do the absolute value part, meaning anything that's negative just gets flipped to positive. So my best advice is do it in stages. I tend to do the regular part of the graph before I even think about the absolute value. I'm just not good at doing that in my head. I tend to make mistakes too much. Okay, Devin.
I had a question on the Ferris wheel problem. So that's
Tell
question.
me in what packet.
Uh, the most recent review one, so 6.11.
Oh, yeah, yeah. Okay. Yes.
Just 14b.
Oh, yeah, 14. I'm going down. Yes.
Okay, so when I was thinking about it, because it was 30 degrees,
Yeah,
it's like increased by pi over 6.
right.
But for some reason, like in the answer key, you did this whole process with like 73 minus 35.
So what I did is because I think this can be confusing to people. So I wanted to show, so if your starting point is at 30 degrees, so if this is 30, so 30 degrees higher from the start, I wanted to show people how you could solve this using a systems of equations. Because sometimes it can be sometimes these things can be more complicated. So if you can always find a point, then you can use a systems of equations. So for example, what did you get in part A? It was part A was negative 70.
Yeah, it was negative 70 cosine
Yep,
2 pi over 3t plus
yep,
70.
plus 78. Is that what you said?
73.
73. Yeah. Okay. So I said in part B, we're thinking about it's going to be a shift. And how did you think about it? Actually, if you use the systems of equations, it doesn't matter. But how did you know which way it was shifted if you didn't use the systems of equations?
Oh, well, I guess I kind of just, I mean, I saw 30 degrees, so I just instantly thought of pi over 6. And because I knew it started from negative 70 cosine, I just knew that everything would have to be shifted over right pi over 6, so I just added.
So you just, everything would have to be, okay, but shifted over right, remember, means you're actually shifting the graph left.
Oh, yeah, adding shifts left.
Yeah.
Oh, okay.
Which actually is right in this case, but I think conceptually people can trip themselves up when they can overthink it. You're not wrong, but so that's why I wanted to show people that kind of the way to be certain is to think about, because you know it's a shift, right? So to think about f of t is negative 70 cosine. Here's my b value. And I know it's going to be shifted. You can do plus or minus c. When you solve for c, it'll come out whether it's plus or minus. So I said, okay, so say I don't know, say I'm a little bit unsure about how I'm shifting it. Like you said, you thought plus pi over 6, that made sense to you, but say I didn't know and say I started overthinking it. So then I would think about, okay, what's a point I can plug in? Because this is now my time 0, right? Because I'm starting here. So if
Yeah.
this, so t is 0 here. So when I plug in 0 for time, I want to know what is this new height here. And the nice way you can find, and always if I give you one of these angles, you'll always be able to find this because this is y equals 73, our midline. And how I can find this height is this right here. I can create this right triangle, which is a 30, 60, 90 triangle. And I know my radius is 70. So opposite the 30 would be 35. And so opposite the 60 would be 35 root 3. So if I want to find this height, I'll just call it, let's just call it x. If I want to find that height, or the output, the height when time is 0, that'll be 73 minus this here, 35 root 3. So that's why you saw me set up this equation f of 0 equals negative 70 cosine c, because 2 pi over 3 times 0 is 0, plus 73 equals 73 minus 35 root 3. So that's what I did there, Devin.
Oh, okay. That makes
And
sense.
because that's a sure way you can always do it. And if you're psyching yourself out, you can kind of have a sure way to figure out what it is. And then you get cosine of c equals root 3 over 2. And I know because instead, so my lowest point is to the left of that. So I know that I'm starting time 0 would be here. So it should be when I go to find what my C value is, that helps me figure out what value I'm going to plug in to actually find that C value. Because remember, you have to be exact with your angles there. So that helped me figure out what value am I actually going to plug in for C. And time, that's why I would plug in pi over 6. Because it would be it corresponds to a quadrant 1 angle. If this is my starting point, then this would be a quadrant 1 angle.
Okay.
Liam, back to you.
I was wondering for 6G how you would graph inverse cosine of cosine.
Oh, yeah. So the best way to do these, and there's a ton of different ones you can do with this. And so to really, you need to know the domain and range, that's for sure, because you need to know what to put on the x-axis and y-axis. And the domain is going to be angles. And
Okay.
what angles can you put in?
Um, could you just put in all the quadrantal angles?
Well, the domain is everything, right? But yes, if I'm graphing, I want to graph, it's just easiest to graph those critical points, right? The quadrantal angles.
Yeah.
So yeah, that's what I would put along here, just because those are either the peaks, valleys, or midline points. So that's a good start. And then the what is the range of this function of inverse cosine of cosine of x?
I got it was 0 to pi.
0 to pi, right? So that means the range is quite limited. It's just um, pi over 2 and pi. So the interesting thing here, when you could go point by point and not a bad idea, but also notice that inverse cosine of cosine of x will undo each other as long as x is an angle that is in quadrant 1 or quadrant 2, right?
Okay.
Because if it's in quadrant 1 or quadrant 2, the output of inverse cosine is quadrant 1 or quadrant 2. So that means this function just equals x for any angle between 0 and pi. And you could, again, you could have gone angle by angle and seen that, but does that make sense to you? Like if as long as x is an angle in quadrant 1 and quadrant 2, when I take the inverse cosine of that, because the range of inverse cosine is quadrant 1 and quadrant 2, it should spit back whatever I put in. So
Okay.
if that's the case, that's just the line y equals x.
And
So
then, uh,
go ahead.
so like for things outside of Q1 and Q2, would it then just repeat what was already put on the graph?
Yeah, so now so that's when I was like, okay, I got that part. Now if I put in 3 pi over 2, so say I do inverse cosine of cosine 3 pi over 2. Well, cosine of 3 pi over 2 is 0. And inverse cosine of 0, I'm back at pi over 2. And so then I do 2 pi, inverse cosine of 2 pi. Well, cosine of 2 pi is 1. And inverse cosine of 1, well, that's back to 0. And so it goes like that. And then I can do the same in the negative direction. So it's going to repeat this. And I frankly, when I first did this, when I first got this problem myself, I did angle by angle just to get a sense. I kind of knew this part, but I wanted to get a sense of what was happening with everything else.
Okay.
Jalen.
Hi, do you think you can, for the name that graph, do you
Yep.
think you can go over like when you set up the equations, can you go over like the differences for when you factor out B to C and like when you don't?
Sure. So like a good problem to think about when I do factor it out would be, yeah, I'll do two different situations. The first situation is like number 3 that I have. So number 3 is actually 3 is too easy. Let me not do 3. I feel like I have another one in here. Where was the other one? Oh, here we go. Yeah. Let's do this one. So whenever I have a midline point or a high or low point, that means that can be my starting point, right? And so that means I actually know the shift of the graph. So in this particular case, I have one point that's not a midline or a high or low. Do you agree with that?
Yeah.
Yeah, so that point's not helping because I want to if I'm going to do a sine or cosine function, I want to have a midline or a low point that I'm dealing with. Otherwise, I have to straight up do a systems of equations because I won't be able to find B or C. But in this case, I do have this low point. So if I think of that as my starting point, in other words, if I think of I'm shifting, normally if I had a negative cosine graph without a horizontal shift, it would look like this. So how am I shifting this graph to line up with what I have?
Well, I mean, you're just shifting it to the left, so it'd be
Yeah.
plus.
Yeah, so I'm shifting it to the left this amount. So when I actually know the shift that I'm doing, so I know the C value, that's the C value after you've dealt with the period change. So that's going to be the case where, and that's what I would do here. It's a cosine graph. What was the amplitude here? One, two, three, four. The amplitude was three, I think. So y equals -3 cosine. I don't know the b value yet, but I do know after I've dealt with the period change, I'm shifting it to the left 7/2 like that.
Yeah.
Um, and then I've got the what was the vertical shift is 1 plus 1. So that's a case where because I have a lower high point or midline point, I can say right away plug in what the horizontal shift is. And again, it's a horizontal shift after the period change. And when it's in this form, it means first you're dealing with the period change and then you're shifting. And one good way to test if you're like struggling, oh shoot, do I factor out the B here? Do I not factor out the B here? The best way to test that is remember, this is your new like 0 point. We're saying this is your starting point. So it should be the case that when I plug in x's -7/2, I'm taking the cosine of 0. If I do, am I going to take the cosine of 0 if I plug in -7/2?
Um, no.
I'm not.
Oh, oh, sorry. Can you repeat the question? You kind
Okay,
of cut
yeah.
out there.
So remember, we said this, we're thinking of this as our starting point. In other words, this is like my new 0. Like it's a graph that this is what I'm thinking as my like I'm shifting, the graph is going to be shift to this location. So I'm thinking of this as my new starting point. So this should correspond to what would originally be my 0. So if that's the
Yeah.
case, when I plug in -7/2 for x, if I've done this correctly, I should be doing the cosine of 0. So if I
Hmm.
plug in -7/2 to the way I've written it, will I be doing the cosine of 0?
Yeah.
Yes, because -7/2 plus 7/2 is 0. Now compare that to if I goofed and said, oh shoot, I don't remember, is B factor out or not? If instead I wrote it like this, notice what happens if you plug in -7/2. Are you actually doing the cosine of 0 now?
No.
No. So that's your telltale sign that, uh-oh, that I didn't do the shift correctly.
Hmm.
So that's a case when I know that I'm not calculating the horizontal shift. I know it based on the points I have. Does that make sense so far?
Yeah.
Okay, so sometimes, and I'm going to open this up, sometimes um, it can be really annoying because when I give you the hardest types of problems are when I give you 2 points and neither are a like high, midline, or low. So let's see if I can pull this up. Name that graph. Here we go. So that was, I gave you a high and low for a few of these here. Midline I gave you, high I gave you. So this actually, yeah, that's a midline. Um, yeah, this is, although you could figure this out a different way, but this is an example where notice I'm not giving you a midline point or a high or a low. So
Yeah.
this would be the case because I'm going to use a systems of equations to find both the B value and the C value. I'm going to, and say I make this my starting point. Say I want to do a sine graph, I do y equals, let's see, what is so 2, 6, 3, -1. -1 plus 3 sine bx plus c. Then I might write it like that.
Yeah. And then you don't have to like factor out B for that,
Yeah,
right?
and because you don't want to solve for BC, B times C, right? So just yes. So just leave it like that. If both are unknown, you can just solve it in this equation.
Okay. Yeah.
Does that make sense?
Yeah.
Okay. All right, Alan.
Ms. Jensen, can you go back to the Ferris wheel problem on the review packet? I had a
Yeah.
question on how you were like explaining like which quadrant you knew it was in, but I didn't really get that.
Oh, yeah. So if I were to visualize, for me, it's helpful to figure out if I were to put this to a graph, right? In part A, if I would put what's happening to a graph, um, the midline's at 73, right? So here's my midline. Pretend that's at 73. So and then it's starting at its lowest point, right? It would be starting here and it's a cosine graph. So then it's looking like this. That was part A. Does that make sense?
Uh-huh.
Although I'm not going in the negative direction, but because I'm not going negative time, but yeah, the positive version. Okay, so now instead of starting at 0, I'm now starting at a point that is higher than sorry, let me rephrase that. Instead of starting at the lowest point, this is the lowest point where I started at point A. Instead of starting there, I'm starting a little bit higher. So that means, again, let me grab my midline. So that means this starting point is going to be the time 0. Remember, this is t equals 0. The starting point will be a little bit higher than the lowest point. So if this is my lowest point, it's going to be a little bit higher. So this is my new graph. Again, this would be originally was my starting point, but now at time 0, I'm starting a little bit higher. But think of when we create a cosine graph, we always have our reference point that we think of, okay, if I was doing a cosine graph with a negative amplitude, I'd be starting here. And so then when I figure that out, I then start labeling the quadrants because the key is when you plug in a point, you want to know exactly what angle that corresponds to. So this would be a quadrant 1 angle and then quadrant 2 and so on. So that's the idea here. That's how I know when I am solving for C, my answer should be a quadrant 1 acute angle.
Okay, and then because it's quadrant 1, that's why C is positive.
That's why C is positive, exactly. That's why it's pi over 6, right?
Okay. Thank you.
But as Devin may have noticed, it is true. Oops, sorry, that's my dog. It is true that also in these problems, if you do enough of them, you realize that when you do a shift like this, as long as it's a shift to the right, meaning like an angle to the right here, not a shift to the right, because actually we're shifting left, but an angle to the right, it's going to be plus the starting position. It's just how it ends up, but I don't like to memorize things. That's why I like to do the system of equations because it can always work. But it does, when you do enough of these, you realize, oh, wait a second, it's just part A. And then if it's 30 degrees, it's plus that 30 degrees. If it was 45 degrees, it'd be plus pi over 4, and so on. Okay, Jackson, what's up?
Hi, could you go over like the rat problem? Like I understood it, like the method was simple enough, but how are you thinking about it to set it up like that?
Yeah, I know. It looks like it should be so much more complicated, and then you start second guessing it because it seems too easy. So you've basically the rat is starting at point A, right? And then you've got your gun here at O that and so at time 0, nothing's happening, right? Rat's not moving, no bullets are fired. But then I'm saying that the rat is moving at a rate of 7 centimeters per second. But I'm caring about so when I'm thinking about actually aiming at the rat, I care about the distance what's the distance, how relative to time that the rat's going. So, and also I'm like, it's running along this line. So I really want, if I'm going to create a triangle in relationship, I want distances. I don't just want rates. So and remember, distance is rate times time. So to capture the distance the rat is going at any unit of time, it's going to be just the rate times the time. So as soon as from go, that's what the rat's going at. Whereas in terms of the rate of the bullets and the distance, capturing that distance will be 25 centimeters per second times time. So that allows me to capture the distance because for a triangle, I need the distance formula. So if I want to know what beta is, it turns out it's always going to be the same because what's the relationship between these side lengths and beta? What's the trig relationship?
7
Sine,
over 25.
sine beta,
Sine beta equals 7 over 25.
7t over 25t. But then because t's are the same, that's going to reduce. So it turns out that beta is always going to be this constant inverse sine of 7/25.
Okay, thank you.
Yeah. Devin.
I had a question on like back to 18.
Back to 18. All right, here we go. Wait, which one was 18? Oh yeah.
Okay, so I got to like the whole cosine thing,
Yep.
and then I plugged in the point 43.6 comma 2.5.
Yep.
But then I got to the point where it was negative 1/2 equals cosine of 32 over 3b.
Okay, so let me just make sure you started off, you were starting off with this same equation as me to begin with. Just double checking you were doing a negative cosine.
Yeah,
Okay, so this is your starting point. Okay, so then you end up when you plug in the point, you get cosine um, B, what do you get when you plug in 43.6? What does that end
yeah.
up being?
It was 32 over 3b.
Okay, 32 over 3b equals what?
Negative 1/2.
Negative 1/2. Great. Um, okay, so let's think about, and is your question what angle that is?
Yeah, so I got 32 over 3b equals 2 pi over 3. But for
Okay,
some
so
reason,
that's your issue. That's where you're wrong.
okay.
So the reason you're wrong is here's your starting point, right?
Hmm.
And notice one full period is to this point. So
Yeah.
even though you're right with the quadrant two angle, it's more than one period, it's over one period away. Does that make sense to you?
Oh, the 43 over 6 comma 2.5 point is the
That
one.
point is a quadrant two angle, but 2 pi away from your starting point.
Mhm.
So it should be 32 over 3b should be 2 pi plus 2 pi over 3.
Oh, okay.
So that's why, like, if I'm labeling, it's quadrant one, quadrant two, quadrant three, quadrant four, and this corresponds to my like 2 pi. If
Mhm.
this corresponds to my 0, this is my 2 pi. And so then when I'm getting to this point, it's over 2 pi. It's a quadrant 2 plus that. So that's 2 pi plus that quadrant 2 angle.
Okay.
So that is crucial. Like that's one of the biggest things that people mess up on assessments with this is not only the right quadrant, but making sure that it's like that you're checking. Is it more than a period away? Is it a negative angle? So that's important to keep track of.
Mhm.
Liam.
I had a question on 19A for like simplifying the trig identities.
Yeah.
Because I was getting like fractions over fractions when I was trying to like substitute for like secant or cosecant.
Yeah. So there's so many like different ways to potentially go about this problem, and some are going to be longer than others. So it depends on what your strategy was. What was your strategy?
I was just trying to like put everything into like back into like normal trig, like 1 over for secant. I was doing like 1 over cosine minus sine over cosine, and then for the for the denominator, I was just doing like 1 over cosine times 1 over sine.
Yeah, I mean, that's just going to be a long route, but it will eventually get there. That's actually how I started. And I was like, oh my God, this is ridiculous. This is taking
Yeah.
too much time. So then I was like, so then I abandoned it. And I was like, you know what? If I FOIL this out, I'm going to get some squared terms. And I know there's a relationship between 1 plus tan squared is secant squared. So I was like, maybe if I do that, I'll be able to simplify. Like if I FOIL out secant x minus tan x, that's one thing I noticed. And also the other thing I noticed is what can you factor out in the denominator?
I factored out secant squared eventually, but for this, I guess you could do cosecant.
Yeah, so that's how I started. Once I abandoned what I had originally started and it wasn't going anywhere, I ended up foiling out the numerator, so squaring that out and seeing if I could use this identity at all. And then I recognized, oh, wow, things were going to be so much easier. So try that.
Okay.
Ryan.
I had a question about converting a sine graph to a cosine graph.
Yeah.
I should name that graph.
Yep.
Because from one of the problems that you already modeled, like I found it in terms of sine, and I was wondering how I would convert to cosine and also vice versa. So
Okay.
I
Yeah, go
so
ahead.
the equation I ended up getting, or doesn't really matter, but it was y equals 3 sine pi over 4x plus 3 pi over 8 and then plus 1.
+1. Okay. Yeah. So the nice thing is for whether you're going from sine to cosine or cosine to sine, the initial process is always the same because they have a cofunction relationship. So I'm going to say 3 cosine 90 minus, so pi over 2 minus, this whole thing is the angle. So pi over 4x plus 3 pi over 8. So I'm subtracting that whole thing. And then I'm going to do cleanup inside. So 3 cosine pi over 2 minus 3 pi over 8 would be 4 pi over 8 minus 3 pi over 8 is pi over 8. So this is going to be negative pi over 4x plus pi over 8 plus 1. Are you with me so far, Ryan?
Yeah.
Okay, so then I was just like combining like terms. And you can't report B as a negative. So we need to deal with that. So to deal with that, I'm just going to factor out a negative here. So negative pi over 4x minus pi over 8. And then it's only at this stage that it's a little different for cosine than it is for sine, because at this stage, I know that cosine of negative, this is just an angle, remember? Cosine of negative an angle is just because cosine is even, is just the same as 3 cosine pi over 4x minus pi over 8 plus 1.
And if we wanted to convert, let's say this is the graph we got, and then we wanted to convert this to sine, would we just do the opposite and just subtract pi over 2?
No, you're still going to do pi over 2 minus.
Okay.
You're always going to do pi over 2 minus because the identity is sine theta equals cosine pi over 2 minus theta. And the reverse is true.
Yeah.
Cosine theta equals sine 90 minus theta. So same. It's just the only difference is when you get to this last stage and you factor out a negative to make the B positive. If it were sine of negative an angle is negative sine. So whatever's outside here would become opposite in sign.
Okay. Thank you.
Yeah. How's that problem going, Liam?
Um, I have like like 2 secant squared plus 2 secant times tan x plus tan squared x, then over like cosecant times secant x minus tan x.
Okay,
So
so when you FOIL it out, you got secant squared x minus 2 secant x tan x, right?
I was getting plus oh, okay. I
And
think
then,
I messed up the foiling, so
yeah, I
probably
think I think you messed something up with the foiling because then the nice thing is what's
can
tan
factor
squared
that
x
out.
plus 1?
Hmm?
What's tan squared x plus 1 equal to?
Just secant squared x.
Yeah, so then you get the nice thing here is then you get 2 secant squared x minus 2 secant x tan x. So then you can factor a 2 secant x out from the top, and then you'll see a whole bunch of magic happens. Yeah, so careful with the foiling. Yeah, if you make an algebra mistake, it definitely throws off the simplification.
Yeah.
Jackson.
So when you're doing like inverse cosine and cosine, why is it pointy instead of I don't know, like
Oh, curved?
yeah, curved?
Oh, because notice that it's inverse, it's this, right? Inverse cosine of cosine. Yeah, because notice that actually when you put in values from 0 to pi, so this is y equals, this totally undoes each other. So you're literally this line, y equals x.
Oh, I see.
It literally is a line. There's like, because inverse cosine of cosine x, as long as when you start off between 0 and pi, it is the line y equals pi. Y equals pi, y equals x. And when you're between negative pi and 0, it actually ends up y equals negative x. And then of course it's like shifted over when you get beyond pi. But yeah, it's because they're literally undoing each other. So you're just ending up with the equation of a line, y equals x. That's why. It's not even an equation of trig anymore.
I see. All right, thank you.
It's weird how that is. And sometimes that you just that's why sometimes starting to plot some points can be helpful to see what's happening. Because whenever you have a situation where the input becomes the exact same as the output, you've got to think, okay, this is totally undoing each other, which happens when y equals x. Ishu, what's happening?
Yeah, so for that same kind of like graph, um I kind of get like the sign of inverse like sign um on the outside and then like inverse sign on the inside of x but for like tan would it just be like an extended like y equals x line?
Oh, sorry. So if you were doing, sorry, if it was something like this, inverse tan of tan x.
Yeah.
Okay, well, let's think about that. So, well, all right, this is actually a little bit more complicated because the x is in all reals, right?
Right.
So you'd have some places where it's undefined, right? So the domain here would be all reals except every pi over 2 plus k pi.
Yeah.
The range is all reals, though, of this, which means inverse tan of all reals we know will be negative pi over 2 to pi over 2,
Mm-hmm. Yeah.
right? So if I were to go about graphing this,
Would
uh,
there just it would just be kind of like the y equals wait.
I'm just going to say here pi over 2 pi. I mean, I haven't done this myself, so I'm going to do it how I would do it if I was approaching this, like if I had gotten this as a problem. Negative pi over 2, negative pi over 4. Okay, and then on my y-axis, I'm going to put pi over 4, right? And I'm going to put pi over 2. But what do I know? At pi over 2, it's undefined, right?
Undefined. Yeah.
So it's never going to achieve that. Negative pi over 4, negative pi over 2. Okay, so let's see if we can figure this out. Okay, so I do know that when I put in pi over 4, um, tangent pi over 4 is 1, inverse tan, so it'll be 1, right?
Mm-hmm.
It'll be exactly the same until I get to pi over 2, right?
Right. Yeah.
So even if I put in like pi over 8, right? It'll be still be, or not pi over 8, sorry, like 3 pi over 8. So something in between here. Then it would
Yeah.
still be outputted the same. But I can't put in pi over 2, right? But it's not going to be like an asymptote. So what do you think it's going to be there?
It's gonna be like almost not really like a step function, but like
It's going to be like a hole, like just like a boop, stopping there.
yeah, it will yeah, it's gonna be kind of like a step function because it's like a hole and then it starts like the line starts right at like pi over 2 or
Right.
negative
So
pi.
right after pi over 2, that's exactly right. Then what would happen? Like right after pi over 2, like so say I put in 5 pi over 8, then yeah, let's do this actually. So if I did inverse tangent of tangent of 5 pi over 8. Like this is an example of a problem I could give you, right? How to tell me it's certainly not 5 pi over 8. Why isn't it 5 pi over 8?
Well, because you have to kind of like consider like wait. Like yeah, you have to consider like the domain and range, right? Like
Right, it's
make
greater than
sure
pi
it's
over 2. So it's not going to be, so what is it going to, what is this equal, in other words?
well, would it be like negative 3 pi over 8?
It would be negative 3 pi over 8. Exactly. So it would be negative, and negative 3 pi over 8 is, where is that? Down here.
Uh, it's like
It's like kind of down around here,
yeah, it's like
right?
right below negative. It's right like well, technically right before negative pi over 2,
Yeah, so it's kind of down here. So if I did, so
like
3,
halfway there.
what did I put in 5 pi over? Yeah, this is 4 pi over 8. Yeah, this would be 5 pi over 8, halfway between. So we said 5 pi over 8. When I put it in, it would be down here, right?
Yeah.
And what about if I put in 3 pi over 4?
Um, 3 pi over 4. Um, wait, that would that still be
3 pi over
in
4 is negative 1, and inverse tan of negative 1 will be negative pi over 4. So down here.
right? Yeah,
And
yeah,
then when
yeah.
I put in pi, tangent of pi is 0. Inverse tangent of 0 is 0. So it
0, yeah.
ends up, it's actually a cool graph. It ends up,
It's like the tan. It's like basically like a step function version of the tan function, tan
yeah,
graph, right?
no, yeah, kind of like that. And there's this like, so it just is, instead of connecting like the cosine and sine, it
Hmm.
has the undefined, instead of, at first it's up here, but then it goes down there. And then it will just keep
Right.
on repeating itself.
Okay.
But that's something like, as you saw, that's something that in order to figure this out, I actually have to plug in some points myself just to get the pattern of things. So it's not like
Okay.
I see this and I'm like, oh, I know exactly how this looks.
Yeah.
Um, I literally have to plug in some points to figure it out myself.
Okay. Will this be like one of those last problems like where it's like almost like a we haven't like necessarily like learned it, but
I mean, you could do this type of graph like this. This would have been
I
a
mean
good
it's not
problem.
like
But obviously,
yeah.
I've made the test and I didn't put it on it if I'm figuring it out myself on the fly here. But it is a great
Okay.
problem. Yeah.
Okay.
And in fact, I did something similar, not inverse tan of tan x. In previous years, I think maybe I did this in previous years. I definitely like a few years back, the one that I put in here was on a test, that cosine one. Um,
Yeah.
so
Yeah,
yeah,
yeah.
it totally could have been fair game, but I mean, I didn't put it on it because this one actually, this one's a little bit more, this one's slightly more tricky. Whenever it's undefined, it is more tricky. So
Okay.
maybe it's a little, I'd have to shorten the test in order to give people time to do that. Whereas,
Okay.
and because sine's not undefined and cosine, those are a little bit easier.
Okay. And then if it was like flipped, like if the inverse tan was inside the parentheses, like that would just be like a straight line, right?
So
Like
that's a go so that one, and Marone, I see your hand. Don't worry, hon, I'm gonna get to you. That's a different story. So actually, like if it was tan of inverse tan of x, the interesting
Mhm.
thing about this is actually I could write this without trig because I could set up a triangle to see what this function would be without
Mm.
using trig. So to set up a triangle, I would, although this one's easier actually, because yeah, you're right. It would be y, it would undo each other. It would be y, you're right. It would be y equals x except for things. But if I set up a triangle, it would be x1. Sorry, I was thinking of something else. I was thinking if I had given you this sine tan -1 of x. But yeah, you're right. So if it was something different, if it was tan -1 of x, the input now would be what? What is the domain in this case?
Well, the domain would be just the um wait, shoot.
Domain is the ratios, which can be anything. So there's no restriction on
Right.
the domain. But then the output would be negative pi over 2 to pi over 2 from inside. So you're only doing tangent of negative pi over 2 to pi over 2. And so you want to think about what values would that be? And that truth is it would be everything, right? Because
Okay, yeah.
yeah, so you could do that. And then again, you could plot some points and go about it kind of the same way as the other one.
Great. Thank you.
Marone.
Okay, super quick. So this is in 6.10b. It's just like rewriting the sine function as the inverse of sine function as an inverse cosine function. And I was confused on where to put the negative.
Okay. Yeah, I think I know what you're talking about. Let me pull it up. 610b. Yeah, 610b is I feel like it's a good worksheet to look at because it had a lot of inverse trig stuff. And I haven't assessed you on that yet. So that's gonna play a decent role in the test. Okay. All right. So tell me which one, Maroon Hunt, again?
It's number 3. Yeah.
Oh, yeah, yeah, yeah. Okay. So in order to do this, you really need to know what the graphs look like. Like I can't do this without knowing the graphs. So let's just quickly, the inputs -1 to 1, right? And the outputs negative pi over 2 to pi over 2.
Yeah.
So when I graph this, sine of 0 is 0. At pi over 2, it's 1. Negative pi over 2, it's -1. And I like to kind of turn it to the side to remember that, oh yeah, the like hills turn into the angles. So it looks like that.
Okay.
Because if I were graphing the angles along the x-axis, like I literally turn my page and remember, oh yeah, so the trig function would be going like if it were continuing on, it would be going towards the angles like that.
Mhm.
So that's the graph of the first one. And then so that's the inverse sine. And then the inverse cosine, 1, -1, and then 0 to pi, right? Pi over 2. And at 0, it's 1. At pi over 2, 0, and pi -1. And again, I think of going like into the angles here, like that.
Uh-huh.
Okay, so basically, I want to manipulate the cosine function so it equals inverse sine of x. So inverse sine of x equals doing what to the cosine function is the question. So there's two ways to think about it. I think in my answer key, I thought about it. Well, what if I flip it over the x-axis? So if
Mhm.
I flip it over the x-axis, it looks like that.
Okay.
So that would be negative. So that means negative outputs, right? When you flip it over, the y values change.
Mhm.
And then what would I have to do then so it lines up with what this looks like?
Shift it up pi over 2.
Yeah, plus pi over 2. So that's one way to
Okay.
think about it. Some people thought, well, what about if I flip it over the y-axis instead? So it looks like this to start, which you could do, but that means you're changing, you're doing like negative x value. So you would do cosine inverse negative x. And then
Mm-hmm.
if you did that, how would you have to shift it to line up with what sine is?
Subtract pi over 2.
Yeah, either one.
Okay. Okay, that makes sense.
But I can't do that until I see the graphs. But once I see the graphs, then I'm like, oh, okay.
Okay, thank you.
Yeah. All right, people. I'll be obviously at school tomorrow. So if you have more questions as you work through things, come by during tutorial.
Thank you.
Bye, guys.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.